I recently did a video about the release of TypeScript 5.5, but there's an interesting feature in TypeScript 5.4 that I never got around to talking about. So let's do that today. The feature I want to talk about is called No Infer, and it's a way for you to control how TypeScript infers generic types in your functions. Let's take a look at a basic compare function here, right? We want to compare two things, and for now I just have a basic implementation in here, but you can see what's happening is we're saying compare takes some type t, and we expect both arguments, a and b, to be of that type t. And TypeScript often in simple examples like this does do exactly what we want, where we have a and b, we need them both to be of the same type. And so we have an error here. The argument of type string is not assignable to a parameter of type number. If we look at the type of compare, you can see that TypeScript has inferred that number is the value of t, and so it expects a and b to both be of type number. But where did it get number from? Well, it basically looks at the first usage of t. If we change 1 here to be something else, like new date, our error now is string is not assignable to type date. And if we look at the type of compare, we can see that compare is now date. And so TypeScript has inferred the type of t based on the first argument a, and then it expects b to follow suit. Now in a simple example like this, inferring from a versus b doesn't matter too much. We just want to make sure they're the same. However, if for some reason we wanted to infer the type of b and then make sure a follows that type, the new No Infer utility that we have in TypeScript 5.4 helps us with that. So we could wrap our t here in a No Infer. And now what happens is we're basically saying a should be of type t, but don't use the value of a to infer the type of t. So now we're just going to use b. And now you can see our error actually switched here. We now get that argument of type date is not assignable to the parameter of type string. So now we're letting argument b guide the inference for t, and a has to follow. So in a compare example like this, that's not particularly interesting. It's pretty basic. Let's look at a few other examples. We're going to start with a simple menu example, which is, this is pretty similar to the example that you'll see in the TypeScript docs. A lot of other people making tutorials like this are using a similar like state machine example. Basically, we have a list of types t, and we want to choose an initial value. Now, let me, spoiler alert, I'm going to drop the initial t there. But basically you can see we're creating a menu where t is expected to be just a list of strings. We can create our menu from a list of strings, and then we have an initially chosen value. So this is like the default, if you want to say. But then in the usage here, you can see we can create a menu with options new and open and save. And then we can say the default or the initial value is close. And right now we don't have any type errors here. In fact, if we look at the type here, we can see that the inferred value for t is a union of all four: new, open, save, and close. So that's maybe useful in some cases and is the default behavior for TypeScript, where we're just inferring from all usages of t. Now, you'll notice this is a little bit different from what we saw in our first example, where we kind of had the inference in the first argument and we had to follow it in the second argument. So we don't get that behavior here. Now you might point out that this is kind of the opposite behavior of what we saw in the first example, where the first argument provided the inference and the second argument had to follow it. Why do we not get that here? Well, I think it's partly because we have this t extends string in this case, right? And this is already providing some narrowing and kind of adding an interesting complexity here. If we removed t extends string and we just had a t and a t of an array and a t, then if we look at create menu, it's inferring just string. And so now if we were to change this to say number 1, then we do get the same error. Number is not assignable to type string. However, because we're saying that this is something a little bit more complex than just some type t, we want to make sure that it follows some other narrowing here. And so when we say t extends string, I think this kind of sets the inference to say any value of t that could be a string is an acceptable value, something like that. To be honest, I'm not exactly sure what's going on behind the scenes there, but this at least is not really what we want. Now, without No Infer, there are a couple of things we could do here. The main one would be to create some other type s and say that that type s extends t. If s extends t, and then initial here can be s instead of t. So t extends string, and then s has to be within whatever t is. And of course, this gives us an error, which is exactly the error we want. Close is not assignable to parameter of type new or open or save. And so we can have all three of those values there. However, adding an extra generic argument isn't always desirable. One reason why you might not want to add a new generic argument is because if you do want to declare it when calling create menu, you always have to declare all the generics that have been given. We couldn't just declare T and then expect S to be something else. So for example, this would really be kind of a lame way to do this, I guess, for this example, where we could say create menu, we pass it our generic, and then that is how we set this here. Now, notice we have a type error, expected 2 type arguments and got 1. We expect 1 for S as well. We have to include S. We would have to say the second one is new or something like that. And so now we have to declare S. And this would be terrible because now we have to duplicate all of this information. We have to put the entire list. We have to put the initial value for that list, which could only be one of those. I guess if we wanted it to be all, we would have to do new or open or save. And that just gets really wordy. We're putting that in twice. And now close is not assignable to new or open or save. And so it'd be nice if we wanted to do it that way. If we didn't have to do this extra argument, right? We can do this. And then I guess this is a little bit better. And now we do get the error we want, which is that close is not assignable to new, open, or save. But we do have to include this when we know TypeScript can infer it from this. Hopefully that didn't sound too confusing. If it did, just remember that NoInfer is here to reduce that confusion. What we can do instead is say NoInfer on this T. So we're going to use this T to do the inference. This T just has to follow along. It doesn't have to provide new information. We get the type error we want. Close is not new, open, or save. Let's go ahead and replace that with new to remove our type error. So this is a nice example of giving a list of possible things and then choosing one as your default. This way, the default is not adding to the list, but we make sure that it is already part of that list. The menu or default parameter or starting position example is an interesting one, but I think I have an even more interesting example. So let's go with the basic setup of we have a bunch of user types here, right? Standard, admin, unauthenticated user, and we distinguish based on this discriminating type field. 2 different functions here. One function can return either a standard user or an admin user. The other one can return a standard user or an unauthenticated user. And so we have 2 users here. One of these is either a standard or admin, and the other one is either a standard or unauthenticated user. How can we write a function that allows us to narrow these while also accepting the right type of user? We're going to call this function isTypeOfUser, okay? And let's come back to the generic for a second. Actually, we know we're going to have a generic T, of course, because of this example. But we're going to have a user that, for simplicity, is just going to have a type of T. And then we're going to accept a type T as our second argument. And really, this is simple. We just want, does user type T equal type, right? That's absolutely the implementation of this function. We're not doing anything to constrain the type of T. So what we can do in this case is we can call isTypeOfUser. We can pass it user1. And first of all, we can just pass it absolute garbage just to show we can do the same thing for user2. And there's nothing to show us that these are not valid types, right? And so you might think, okay, well, the first thing to do is to say this extends, and we kind of want this to extend, T to extend the possible user types, right? Well, we don't have that yet. So let's just go type user, right? So we have this type that represents all of them. And then we can say T extends a user square bracket type. And in that case, okay, great. Now we actually do get a type error here. It's not assignable to standard or admin or unauth. Let's replace this unauth. So this kind of looks like this is doing what we want and we didn't even need NoInfer. However, there's something we can do further here. We know that user1 is either a standard user or an admin user. So we know it's never an unauth user. If we already know that about this variable in like our compile time checks, then why can we not say, hey, you're doing a check that really you shouldn't do? Same thing with user2, standard and unauthenticated. It's never an admin user. How come we can't tell that? Well, this is where NoInfer comes in. Right now, there's actually, even though we've said T extends this user type, we are actually inferring values based on what we see here. So we're really just saying, make sure T match this constraint. Whatever type T is here for our second argument, does it match the constraint? But instead we can say NoInfer on our second argument's T. Now you can see we have our NoInfer in the argument here. Now we're getting the error we want. So we can see that user1 can never be unauthed. So why check for it? So we can change this to be admin. User2 here can never be admin. So let's change this to check for standard. And now we have no type errors here. We have kind of the best possible typing here because we're not inferring based on the argument. We're using the inference of our first argument to dictate what our second argument can do. So that's a quick look at No Infer in TypeScript 5.4. Of course, we're on to TypeScript 5.5 now, but of course, No Infer is still there and still useful. So if you hadn't noticed that yet, hopefully this gives you a chance to check it out. Thank you so much for watching, and I will see you in the next one.